All right, Olivia Wyndham. What'd you get for square root of 108?
About 10.39.
That's not simplified. That's just putting it in the calculator. Colt?
1,039 over 100.
No. Colt's right. Factor it. 36 times 3. So it's 6 radical 3 because the square root of 36 is 6. Right? That's what we're looking for. We're going to be doing a lot of this today. All right? This is stuff that you should already know how to do. Okay? All right. 6 times 24, what's that equal?
12.
6 times 24 is 12? Oh, you mean it's square root of 144? Is that what that comes out to? All right, which is 12, yes. What about the fraction one? What's 3 in the 42? How many times? 14? So it's just the square root, negative the square root of 14? 14 does, this 2 times 7, you can't pull anything out of it. All right. Now, how do I do number 4? These are both positive perfect squares. Okay, so we can make this a 0. Does the one, my little 1, 2, 3 thing work? Is 8x half of 18x? No, it's not, is it? Are there factors of 16? Let's see, 1 times 16, not 18. 2 times 8, not 18. That's only 10, right? 4 times 4, that only adds up to 8. So there's no factors of 16 that add up to negative 18, are there? So we're going to have to complete the square. All right? So we're going to have the x squared minus 18x plus blank. And then when I move that 16 over, it becomes negative 16, right? What goes in my blank?
Why would that be negative 16?
Because if I put the 0 over here, I'm going to move it to that side. Right, move the 16 to the other side of the equation because I have to find the zeros. Okay, I have to subtract it. What goes in the blank? 81, very good. Half of 18 is 9. 9 times 9 is 81. So this is x minus 9. Square root of that, that's sine the square root of 81. And what's 81 minus 16? 65. All right, and then I do what to both sides? Square root. Whoa. So I get x minus 9 equals plus or minus the square root of 65. 65 is this, what, 5 times 13? Nothing I can pull out of there. So I just add the 9. So it's 9 plus or minus the square root of 65. There's my 2 zeros. Number 5, same type of problem, right? Are there factors of negative 24 that add up to 8? We got what? 1 and 24, one's positive, one negative. That won't work. That's like a 1 and 3, right? 2 and 12. That's either 10 or negative 10. One's positive, one's negative, right? 3 and 8. What's that? 5 or negative 5, right? 6 and 4, 2 and negative 2. So it's like this one. We just did. So the x squared plus 8x plus blank. And then I'm moving the 24 over, so I add it, so it's positive. What goes in the blank? 16. So I got 40 on the right, and x plus 4 squared on the left. So when I do my factor tree, when I take the square root, get x plus 4 equals plus or minus what? What can I pull out? 2, right? Come on, keep up. You guys can do this. And then subtract the 4. Okay? So that's using, completing the square to find the zeros, to solve the quadratic function. Okay? And yesterday, for homework, I wanted to give you some problems that were what we were working on yesterday, but I gave you the wrong ones. I gave you 42 to 48, right? Or 58. Oh, there's some down there. But it was solving, again. I wanted to do the ones with the vertex. That should have been 32 to 37. But that's okay. For 41, there was no x. Oh, no, we didn't have to do 41, did we? Okay, that's today's stuff. 42, there was no x, right? So what do we say we could do if there's no x in it? We did that the night before, actually. Do we complete the square? No. Just get the x squared alone. So how do I get the x squared alone? How do I move that 25? Divide, right? What's 0 divided by 25? 0. And then what do I do to both sides? Square root. What's the square root of 0? 0, right? Can I really say plus or minus 0? No. All right, it's just 0, right? So that one should have been an easy one for you. 44 is like that as well. Okay, negative 3x squared plus 6. Was what, 1 or something like that? Negative 1? Okay, so this is like that one. There's no x in it, so just subtract the 6. Negative 7, divide by the negative 3. And you get x squared, 7/3, and then you just take the square root. Now, I can't simplify that at all, but that puts a radical in the bottom, right? We allowed to have radicals in the bottom? No. So I have to multiply, and I got to rationalize. So 7 times 3 is 21, and then 3 times 3 is 9, but what's the square root of 9? 3. So that's the answer. Okay? So we're going to do some simplifying of radicals. 46 was, a lot of you had a question mark for this one. This isn't bad at all. Was it 46? Was it plus 1/4? Minus 9/16? So what do I do with the 9/16? Actually, what's the vertex of that one?
1.
Kind of, but no. What's the x value of the vertex? No.
1.
No. Come on, what's in parentheses? 1/4. So what's the x value of the vertex? Not 1/4.
1.
You guys didn't pay attention at all yesterday. Remember HK? Okay? If it was x plus 1/4, what's the x value of the vertex? Negative 1/4. And what's the y value of the vertex? You can see it. Negative 9/16. Okay? Now what we did yesterday? You had to put it in that form and then tell me the vertex, even though I didn't give you any homework like I should have to do that. All right? But anyway, I'm going to solve this, I have to move the 9/16 to the other side, so it becomes positive, because I'm going to add it, right? Now, what do I do to both sides? Square root. So I get x plus 1/4, what's the square root of 9? And 16. 4, that's an easy one, right? And then what do you do with the 1/4? Subtract it, so it's -1 plus or minus 3 over 4. Well, can I do those two problems? Yeah, you should do them. What's a -1 minus 3? -4 divided by 4? -1. What's -1 plus 3? 2. What's 2 divided by 4? 1/2. So there's our two answers. So if there are whole numbers, there's no radicals, you should finish it up and actually find the two answers. And you should be able to handle that. You guys are smart enough to do that. You guys see fractions and you say, I can't do it. Number 48 was one of those perfect square trinomials. So when you factor that 14x and 49, it's x plus 7 squared. It's one of these. Half the square root of 49 was 7, and when you multiply those, that's half of the 14. And it was 64 here. So then you can square root both sides, so you get x plus 7 plus or minus 8, all right, square root of 64. And then subtract 7. What's -7 plus 8? 1. And what's -7 minus 8? -15. Okay? So that would have been 48, doing it really quick. All right? 50, it said 2 attempts to write f of x equals 2x squared minus 8x in vertex form are shown, which is incorrect. And A was the incorrect one. The third step, they have to remember to when they factored out the 2, it should have been x squared minus 2x plus 4 instead of x squared minus 4x. So they just messed up there. 52 was -21 and -1. So they used completing the square for that. 54 was -3/2 and 4. 56 was 2 plus or minus the square root of 15. And 58 was -5 plus or minus 2 radical 15 over 5. Let's look at 58. That was kind of tough. Why is 58 kind of tough? Why is it kind of tough?
Divide everything by 5.
Yeah, the 5, right? You have to divide everything by 5 first. All right, because remember, to complete the square, you got to have a 1 for your A value, right? Take the 7/5 over, so I added it because it was minus 7/5. What's half of 2? 1. What's 1 squared? 1, right? So it's x plus 1 squared when I factor it. So again, just use your calculator, 7/5, 7 divided by 5, just put in parentheses, plus 1. Enter into decimal, hit math, enter twice, 12/5. And do what to both sides? Square root, right?
Pardon the interruption. At this time, we need 8th grade orchestra and
Right, that's 4 times 3, right?
Please go to the main gym
So
now.
that's 2 radical 3
Please wear your mask
over
your
radical
nose
5.
and make
Am I allowed to leave it radical 5?
No.
8th grade
So I do
orchestra and MS paintball club.
this stuff,
Report to the main gym now for your picture. Thank you.
okay? So, I'm going to subtract the 1 to move it over. This is a 5, right? Radical 5 times radical 5 is a 5, and then that's 2 radical 15. Okay, so you can leave it like that. If you want to leave it in fifths, then you got to make that -5 if you make it one big fraction. That's how the book did it, but if you did it like this, like that, that's okay. That was kind of a tricky one. All right, so completing the square, do we know how to take half of b and square it? Do we know how to factor them into a quantity squared?
Probably.
Right? Going from here to here, we're okay with that, right? Okay, and then once we're there, you guys know you're square rooting both sides, right? Okay? You know, like here, half of 18 was 9 squared was 81, and then you take the square root of both of those, that sign, and square it. Half of 8 was 4 squared was 16, square root of x, and 16 go there, that sign squared. Right? You should be able to do that. Okay, that's completing the square. All right, today we're working with complex roots, non-numbers. Roots, remember, are like zeros. All right, we're going to use imaginary numbers today. Then we're going to solve more quadratic equations, but they're going to have complex roots. So you're going to learn the imaginary unit today. Imaginary number is complex number, real part, imaginary part, complex conjugate. We'll do the complex conjugate tomorrow. All right, so you can see in the graph of what f of x equals x squared plus 1, that's right here. That parabola, you guys know quadratics with an x squared has a parabola. The a value is positive 1, that's why it opens up, right? Stuff we've learned already. It has no real solutions because it has no x-intercepts. It doesn't cross the x-axis. Those are where our zeros are, wherever it crosses the x-axis. Okay? This has no real solutions. Okay? It says if you solve the corresponding equation, all right, if you want to get x by itself, you subtract the 1, right? I don't know why they didn't put it equals 0 there. But subtract the 1, so you get x squared equals negative 1. So when you take the square root of both sides, you got plus or minus the square root of negative 1. Okay? Which, up until today, you couldn't do, right? Can't take the square root of a negative. Right? But there was some mathematician guy a long time ago that said you can find solutions if you define the square root of a negative numbers. All right? So that is why imaginary numbers were invented. So this guy, I think it was Descartes was his name, René Descartes. He was French, mathematician, and really smart dude. He developed this imaginary unit I, the letter I, and what it equals is the square root of negative 1. So then we can find the square root of that stuff, okay? So this is what you got to learn from that. The square root of negative 1 now is I. So if you ever see a negative under the radical sign, you're going to pull that letter I out. That's the imaginary unit. Okay? So now we've got non-real or imaginary numbers. We can finish a problem that has a square root of a negative. So if the square root of negative 1 is I, that means I squared equals negative 1, right? Just like the square root of 25 is 5, because 5 squared is 25, right? So you need to learn this. Memorize it. Remember it. Okay? Because in your problems today, you're going to see negatives under the radical sign, and you're going to see some I squareds that you're going to have to change to negative 1. Like if I had 5I squared, you would change that to negative 5, because that's 5 times negative 1. Okay? If I had negative 10I squared, that's negative 10 times negative 1, so you would turn it into a positive. Okay? So, learn it. Remember it. Don't forget it. Any questions so far? Okay. So, an imaginary number is the square root of a negative number. Imaginary numbers can be written in the form bi, where b is a real number and I is the imaginary unit. The square of an imaginary number is the original negative number. Okay? So they did a couple. The square root of negative 2 is the same as -1 times 2, which is I times the square root of 2. The square root of -4 is like the square root of -1 times the square root of 4. The square root of -1 is the I, and the square root of 4 is the 2, so it's 2I. Okay, so whenever you see a negative, just pull the I out, is what I say. And then simplify it like you know how to do. All right? So these are our imaginary numbers, the square roots of negatives. Okay? So, everybody knows the square root of 121 is what? 11, right? So, again, if you show all the work, this is 5 times the square root of 121 times the square root of -1, all right? But I don't make you do that. Just remember, you have to pull what out? An I. So this is 5 times 11 times I. So it's 55 I. Okay? Any questions on that quick example? So just remember, you see a negative, put an I. And we always put the I at the end, in the back. If there's a radical left, if this wasn't a perfect square, if there was some radical part left, it goes right in front of the radical sign. All right, 96, that's not a perfect square. What are some numbers that go into 96? 12 and 8, all right, we can do that. And then we got 2 and 4, so I'm going to stop with that 4. I got a 3 and a 4, I'm going to stop with that one. All right, so there's a negative sign, so that's part of my answer. There's 2 4s, so I can pull what out? A 4. There's a negative, so what else do I pull out? I. And then what's left in my radical? 6. Okay? So the only thing new today is that negative, right? Pulling that letter I out, the imaginary unit out. You already knew how to simplify radicals, which you're supposed to know. Right? All right, you guys try this one. Come on, it should take you about 20 seconds. 30 at the most. Go down on the pound here. Stand on you. Good job. Good job. You did. Help him out.
So you gotta solve it. So you're writing a number.
Good. Good. Yes.
No, I did wrong.
You know what you did wrong? Good. Okay, usually, that's right. But usually we put that right in front of the radical sign.
Oh, you got the answer?
Correct. Very good, sir.
Law.
Good. Scott, you get that too? Well, that I goes right under the right. So the other.
Would there be a negative or something?
Nope, there's no negative in front of the radical, right? Ken!
You always do that.
That's right.
It scares me.
Yeah, she goes, don't throw that, John. Okay, you guys did well. 4 times 3 for 12, right? What's square root of 4? Negative I and then the 3. So some of you were putting the I in the back there. It's not wrong, but it's supposed to be written like this, okay? So if there's something left under the radical sign like this one, just put your I right in front of that radical sign. All right, what's that? 6I, right? So what's 2 times 6I? 12I, right? All right, so what can I pull out of here? 7 was right. So what about the 9 becomes a 3? What's negative 1/3 times 3? Negative 1, isn't it? What else comes out? I. Radical 7. Making sense? All right, solve it. What are we supposed to do to both sides? Square root. What is the square root of negative 144? 12I. There you go. So it's the same as what we've been doing, but they'll throw some negatives at you that you have to take the square root of. That one makes sense? What do we do first? Move the 90. Then what? Divide by 5. So what's that? Negative 18? Isn't that negative 18? Someone check with me? All right, then what? Square root. We'll just do a different color so you realize what symbol we got to remember. Plus or minus. What comes out front? 3I. Radical 2. That making sense?
Yes, sir.
So we're going to get the squared part alone, and then take the square root of our negative and simplify it in radical form. If you try to put that in your calculator, the square root of negative 18, going to give you a non-real answer, right? Because that's what they are. You can't really do it. But now we can, because we know the square root of negative 1 is I. All right? That one's just plus or minus what? 6. Thank you. All right. Again, those are all the same type, right? All right, there you go. Good job today. Stay focused. Remember, if you get queued up, quarantine, do the work each day. Keep up. Don't blow it off.